Good morning, everybody. My name is Matt Sump. I'm an account executive for Illinois and Iowa here for ShopWare. And then I got Alex with me today, one of our senior applications engineers that will be doing the presenting. Real short overview of what Alex is going to cover here. We're going to cover the multi-axis product first, do a little bit of the deburr, then get into the new unified. And then Alex will get into the lathe and mill turn. Just to give you guys a bit of a heads up, it's going to be mostly mill turn focused. The actual core lathe product updates, there weren't a ton or worth talking about in this release, so it's going to mainly focus on mill turn.
Good morning, everyone. Again, as Matt said, my name is Alex Zuniga. I am one of the applications engineers. I do a lot of the on-site and classroom training here in the Illinois and Iowa area. If you're not from those areas, you probably dealt with Rob or Jeff Elliott or somebody around the Indiana area. So yeah, without further ado, let's go ahead and get into this multi-axis rollout. The first thing I'm going to talk about here is the deburr toolpath. We had a little bit of a ramping up with this toolpath because in the past, if we had a feature like so, where you wanted to get this chamfer cut out, a real deep chamfer, and in one pass as well, we weren't able to use deburr to do that. We would have to use something like swarf machining to grab the geometry. You would grab the upper rail, the lower rail, all the surfaces. You could add tilt lines, all that nasty stuff that you have to deal with, right? Just to get this motion out and about using the flat of the tool. In 2022, we came out with the feature of being able to use a ball nose end mill or a lollipop in deburr to create the same chamfer using multiple passes. As you can see, now I've got the same concept done, but now I have to deal with all those passes, which takes more time to cut. In 2023, Mastercam came out with this new feature in here, and I'll go ahead and just make these quick changes. I'll go back in that parameter. And what we are using is technically a dummy model in here. The edge we have selected is this model here. So we got rid of those edges. We just have the blank section because sometimes those models, they don't have the true size of the edge. Maybe, maybe the engineer just decided to put whatever they wanted on there and just said, call it a day. So we can just grab that edge as we did here, make it whatever size we need it to be. And we can say, hey, I only need one cut. Now the kicker here is in the tool axis control. Once I switch this over to 5 axis, I can use this section here called tool contact. This is the new checkbox here. This allows me to engage a certain percentage up the flat length of the flute here of our tool. So I can say if I wanted 20%, well then like this first part of the tool right here would be engaging that chamfer there. So now that I hit the green check mark, all of those surface pickings, all of that tilt line stuff and axis control and everything that we have to deal with in swarf is basically out the window now. I can just simply pick the edge and say, give me that cut there. And I've got the same exact stuff as a swarf toolpath. The really nice thing about this toolpath as well is you can use flat end mills, you can use ball nose end mills, tapered end mills, and the in any kind of axis depending on where the angle of the flat section of the flute is sitting. So like in this example, the second toolpath I've got here, we're using a chamfer tool in a 3-axis motion. And by default, it's already taking that contact amount for me. It doesn't even let me change it because I'm sitting in 3 axis. So when I backplot that, I've got this deal here. And this is a pretty simple setting right now. I mean, it's just one continuous line. It doesn't have any drops or dips or anything like that, and we're going to get to that portion here in a little bit. But you can also see here, if I use a taper mill, you can see the picture is changing depending on the type of tool that I have. So same exact functionality, different tool. It's just a matter of switching what you want and what percentage of engagement you want. So it's real nice in that case. We also have situations where we would be, back in the day, deburring using a lollipop to cut underneath, right? I have this undercut here. It's a very minor touch. Just goes around and about, right? Just a typical pick the chain and let the ball do the work on that lollipop there. Well, this new feature also works on this undercutting capability. So it's just a matter of switching the tool and switching that checkbox on, and I'll get something that looks like this instead, where the tool is engaging underneath. All right, that's from the bottom side there. If I go ahead and rewind that real quick, I can show it from the top. So it'll just basically pivot from the center there. And it'll do that top section as well. It's a pretty neat thing to do. And like I said before, these are pretty straightforward lines. Well, if I go to another situation here, let me go ahead and open up a different level here. I believe, yeah, here's the one. If we got a file like this, where the chamfer runs up the entirety of the part here, well, what I would need to do back in the day was use edges like here, right? I would use a swarf toolpath to tell it to walk up and over, because this does not stay straight anymore. Deburr takes all that pressure away nowadays. So get that here. It follows it no problem. And all that is just controlled by a very simple checkbox, tool contact. So if you still want to use the ball end of that tool to run that chamfer there, you would just have to uncheck this, and you can still use that deburr toolpath with the ball end. Here's another example of that file here. Let me grab that real quick. And just like any other deburr toolpath, you could set limits so that way you have a amount of tilt here. If I go over to the right side here, let me get to this right. Get to this view right here. At first, you can see when I get to about right here, it's dipping pretty good. You can still control those limits in the toolpath. So here I've got that 50 there, right? So it was dipping, but not too crazy. But if I do this one doesn't have that turned on. You'll see here when I get to about this section, it will dip even further. Do you see that? So you can still control that dipping with that axis control. So all the functionality in the deburr toolpath is still behaving the same way, regardless if you're using the flat section or a ball section. This is even you're even able to use this on a 3-axis capability. If you don't have full 5, you can still output this in 3 if you have the multi-axis package. For something like this, right? If I have this little pocket here, I'm just trying to clean up these edges. I can get down here, and I'll engage with that flat the amount that I told it to engage on. So you can see it'll walk and push away as necessary just to maintain that edge break there. And this is just with an output of 3 axes instead of 5 axes. I can run that with the ball, I can run that with a chamfer now, whichever I choose. So that about pretty much covers the deburr toolpath in there. And like I said before, it is just a simple checkbox down here. And if you're running 3, 4, or 5 axes up here. The next portion I'm going to talk about here is going to be our unified toolpath. So here's a part that I can show off quite a bit of different toolpaths. If you look, I'm going to start to go down the screen here, you can see I've got all these different patterns on here. Many, many different patterns. And they're all done using the same exact toolpath, unified, which is a few different options turned on. So if you haven't noticed in 23 yet, if you're not using 23 at the moment, if you go into your multi-axis menu and hit the drop down, you're going to notice there's quite a few toolpaths missing. You're missing morph, you're missing a long curve, you're missing parallel, you're missing quite a few different options in here. And the reason why that is the case is because this unified toolpath took all of these toolpaths and consolidated into one menu. This eliminates the need to change multiple options over and over again, to create multiple toolpaths over and over again. I can simply set up the toolpath in the way I want it to behave as far as tool axis control, collision control, and all that stuff, and tilting. And then I can change the pattern from there, quite simply. So without further ado, let me get into one of these toolpaths and I can show you this. So I go into this first one here. The biggest change in these toolpaths here is you've got your cut pattern here. And in this cut pattern page, you have different selection options. You have automatic boundaries, you have guide curves, you have surface curves, and then by plane. Well, depending on which one you pick, you'll get a set of options between each one here. So if I'm using plane like I am in this one, I'm just saying I'm using a custom plane that I have selected, which is the work offset plane that I'm working with. And that's going to create the pattern along that XY region of the toolpath. The rest of this toolpath is pretty much all the same stuff we deal with in most of our multi-axis day-to-day operations. So I've got my certain parameters in here. I've got my tool axis control, which I have to from a point. I have my collision control turned on with some retracting. I've got some linking stuff going on here. All the same deal. But when I backplot this, you can see I can get that nice pattern there, right? Here's my point. I don't know if you guys can see that point there, right? It's like a pendulum swing. The tool is never going to leave that point section. So I've got a nice pattern that runs across the entirety of that surface area. All I had to do for the second toolpath was copy the operation and change the pattern. So instead of using a plane selection here, I just simply click this X to remove it. And then I said, give me a curve. And I want to base this toolpath off of guiding off of a curve here. You can see I have several different options here. I can use the old school parallel. I can be perpendicular. If any of you use a long curve toolpath, this is now called perpendicular. It's the same exact thing. They just changed the name. And what I ended up using was that guide. And if I click the white arrow here, you can see there's that line that I'm guiding the pattern to. Again, all I did was copy the toolpath and just change this chain here. The rest of my options are exactly the same. So that saved me maybe 5 minutes or so, depending on what how complicated the access control was and the collision that I had to deal with. All that's out the window now. I don't have to worry about it anymore. All I had to do was change the chain, and now I've got this cross pattern here. If you guys use morph a lot, it's still in there. Same toolpath pattern and all. The difference between the morph and the guide is I would have to click the curve button twice so I can get my morph option, right? Because in morph, you have to select to start at one end, and then you would pick the end at the other end. So this is traditionally set up the same way, and all of the options in here are the same. Nothing changed. When you're programming these parts and you're using Unified, you can check every single pattern to see which one will be the best instead of clicking 2 or 3 toolpaths. You don't even have to make a copy. All you got to do is go back into the parameters and change the pattern. Right? Once you know, okay, I want my tool to stay at this pivot point, then the rest I can deal with just by changing the pattern. See which one I like, and then stick with it. In this particular situation, we used a motion with a dummy model. So let me go ahead and grab that dummy model. As you can see here, I created that same model with some model prepping. I got rid of those holes in the walls and all that stuff. That way I can get a good looking pattern here. And I used an automatic boundary this time. So all I had to do was select the auto boundary and then use the machining regions that I had selected. I have more than one of these. Yep, there we go. So now I selected the entirety of the model, and I got that pattern. When you change these boundaries, if you use, whether you're using guide curves or you're using the auto boundaries or plane, depending on the strategy you're going with, you're going to see the same options under the cut pattern here as the old toolpaths that you're using. So some of these toolpaths are going to have different options here. One of them being like if I was in, let me get back into this morph here. I have this extend edge curves button. Well, some of these toolpaths aren't using curves, right? If you're using surfaces, well, then this option won't be there, obviously. So it knows when to hide certain options, and it knows when to add them when they need to be. So just depending on the toolpath strategy you're using in here, you'll get different options as well. Some of the neater options in these newer patterns, like automatic and guide, allow you to do things like fill holes. If I go back into here, in this particular model, we did not select a dummy model. All I did was pick all the wall and floor surfaces, minus this gap area, obviously. And under the cut pattern, I have an option in here for some of these newer patterns to fill the holes. So it'll fill that hole there. You can see there is a little bit of work to be done regardless on this. If you can see these sections here are walking right over, no problem. But if I go down here, I can see on this giant gap here, there is a little bit of a dip. Not that it would be touching anything, but it would be maybe a motion that I don't want to happen. So there is a double-edged sword behind it, you know, depending on the gap. So we could always use something like this, where I created a model that doesn't have the floor, but it does have the wall still. So I just did less model prepping, and I can use the fill holes option to take care of this section. And this is was a selected surface this time. I had the cap in there. And you can see I've got all these extra passes here. These little trim passes here. On some of these tool paths, I have the ability now to say, let me find that. Trim cut shorter than X amount right here. So lots of good stuff happening in this unified path. So inside of these, I'm going to go ahead and poke at some of these and show you where the old ones are and the new ones are. So the newer ones in the curve section is the guide. You can guide between two curves in the same one or in two separate ones. It's up to you. You can go by surfaces, and you've got your flow, the U and V, so it's like that 5-axis flow, or be parallel to a surface. So this is old. Most of this is older stuff, minus the guide. And then the auto boundaries, you have automatic boundaries for parallel, morph, just a different type of collapsing pattern to the surfaces you have selected. You can start from center out or from outside in. That's basically what the difference is on these in how you have the boundary projected. In this case here, the auto fill holes wouldn't work because I'm using an old school plane selection for my unified. So parallel to a plane doesn't allow me to use the option to fill holes, where parallel using a guide allows me to use fill holes. So depending on the strategy you're working with, you're going to get that deal there. Here's some other different guys here. Some of these I'm using boundaries as well. You can also contain certain toolpaths inside of boundaries. Like this right here. I got rid of all of that choppiness here using a boundary. So inside of the cut pattern here, under containment, it's user defined. You can see there's my edge curve there. Pretty good stuff. Very, very powerful toolpath. Most of these examples I have in here, I didn't change the axis control. I didn't change any kind of collision stuff. I left a lot of that alone and just changed these parameters, the pattern itself. So it's a lot quicker to deal with on a toolpath by toolpath basis. You could even project your curves onto a surface like so and engrave with it. So under the parameters for this one, it would still be a curve selection with a project option. Whether they're 2D or on the actual physical model, it'll grab it and project it onto the surface you select. So now I've got that deal right there. Boom. We do have some tool access control options that are brand new in Mastercam as well, and that's what I'm going to talk about here. In this particular pattern here, I'm using the from a point section here. You can see how the tool never leaves this particular area. It's like a pendulum. And now I can use the same exact motion using what we call a relative surface. And relative surface is a new motion that allows me to stay relative to a particular normal to a face of a part. So you can create dummy faces inside or outside of your part to stay normal too. if I go back into my levels page, I can find that relative boundary. You can see I've got a generic shape of a box matching the overall profile. So I'm saying stay normal to all these faces with some axis control limits, and I can walk across the entirety of this part without any issue of over tilting and overextending these sections here. I got a better example for this one, so let me bring that in now. So you can already see my surface here. Back in the day, if I use a unified with a different axis control, this one is going to be using the tilt with surface. You are at the mercy of tilting with the surfaces you picked to machine. It wasn't like go pick extra surfaces to work with. So in this scenario, you would get the tool coming in, and you can already see where it's going to be a bad day. It's just coming in straight down. There's a lot of extra things here. I could try and use tilt axis limits, but that's probably going to hinder other motions of this file. Right here is good, and then it wants to get normal to these smaller areas. So you can see it pivots down and pivots over. Pivots over. Okay, no problem there. Pivots over, and then right here you have boom, boom. Well, now I can kind of create a shroud that I want to stay normal to. And again, it does not have to be inside or outside of the part. It can be anywhere on the actual file. You can see how this is going inside some sections. All it's doing is staying normal to this area rather than the actual part file. So you can see here, the new option in 23 is tilt relative to reference surface. And then I would just pick that reference surface, and I can choose how much extra angle to add to that normalcy that I want to. So now when I backplot this, I'm going to leave that on so you can see what's going on. You can see right off the bat, I'm coming at a better angle. And I'm going to stay normal to this face the entirety of this cut. So instead of dipping here to here, pivot, pivot, I'm staying flat to this area. And again, right here, we eliminate that extra deal right here. It just walks up and over this time. Let me turn off the shroud so you can see that a little bit better. A lot cleaner motion. This is going to be really nice when you're using other motions like clean core cutting. And I'll go ahead and bring that next file in here. I got Honest Abe here. Give me a hand. So back in the day, you would need a clean core like this guy right here to be selected to stay your pattern. Your machining regions would be this model right here. And then you would say offset. In your collision control, I would say turn on retract and offset my avoidances to the actual model of Abe there. Well, now we don't really need to do that anymore. What I can use now is this tilt relative. Yep. The tilt relative to, I can create myself any kind of a clean core that's better looking, better motion to match the actual model. Like I got this watered down version of Abe without all the detail. And that's what I'm projecting to. And again, even if he's got all those motions out there, all that surface there sticking out, it's a relative. It just cares about being normal to that surface, not where the surface really is. And that'll allow me to walk around this part in a manner that makes more sense. It's a little bit better of a pattern, smoother motion. One of the big things when you're using a clean core versus this relative to surface, when I would get down to a section like right here, there's a huge gap behind his ear right here. Before, what would happen here is this tool, right now you can see how it's angled a little bit differently. It's not making contact with that ear. If I use the clean core method, this thing is going to go straight down onto this section because I have to stay normal to the actual face of the clean core on the inside. So I would get this jagged dip down in the part. So this one, using the relative and something similar to ape shape, will allow me to stay in a better motion. And I have a question here. How did I create that surface? It depends on which surface you're talking about. If you're talking about the dummy version of Ape here, in our mesh tab, we have this motion in here that says smooth area or refine. These options here, they're really nice. If I say smooth area, I don't want to mess up Ape here. But what smooth area would do is it allows me to pick those meshes, and then I can preset certain motions in here, and it'll kind of even it out, make it nice and smooth. Refine kind of has a similar situation as well. And these are STL models. They're not surfaces, so that's how that was built. On the previous file, just in case you were asking about the previous file, go back to that.
Yeah, I think it was probably this one, Alex.
This one right here?
Yeah, I missed when it came in there for a sec. Yeah.
Yeah. No worries. For this particular file, let me hide the toolpath here. We created some tilt lines using normal surfaces or wireframe selection, as you can see here. And basically, in the wireframe tab, I can go in here and click on this drop-down menu where it says line closest. And then I can select something like normal to, or line normal to grid. Right? When I click that face, I can add that to wherever tilt angle I need it to be at. So I've got the line on there, and I can use in this drop-down menu under Modify Length, Modify Vector. I can select that and then tilt it wherever I need it to be. Oops, grabbed the wrong one there. Let's say I need to go that way. See how that's moving around? So I can create those lines as necessary. That's pretty much the strategy we did there. We created some lines, just down, point to point, at that point, or using normal lines. And then I use a surface tab here with a loft. Where the loft is, you just choose all of these lines going in the same direction, and it'll just sweep a surface across the entirety of that, and you end up with that. So basically, you want to make a shape that you want to keep your tool normal to. There's no right or wrong to it. It's how much mobility do you want to allow the tool to deal with in that reference surface. It's a really nice function to use. I think I'm going to use it quite a bit. I mean, I already have been in a lot of my files that I work with customers. So it's a really nice deal to work with.
Yeah, and both those options you showed for creating the lines and modifying the vector, those were, I think, both 21 and 22 additions to the software.
Yeah, they're a little bit older in that case. Let's see. Well, I already finished up with Honest Abe there. But if I go into I got another file here. We're going to go ahead and move on to our mill turn options. So this, at this point, is going to be the mill turn product. And what we are going to cover here is what's called the B-axis contour toolpath. So back in the day, what I would need to do to achieve this cutting motion here, I would need to make sure I got myself a tool that can fit in this angle from all sides. And I can change the angle from here, from toolpath to toolpath and go from there. Well, now, if I want to finish this in one toolpath, I can use this B-axis contour. And what this does is it'll align based off of either an automatic motion or a set of tilt lines to cut in the motion you need it to. So here now I'm cutting in the correct spot of the lip going downward. All right, if I didn't want to use a grooving tool to get all this down, I can use this tool here. So how this toolpath works is I would go into the parameters of this toolpath, pick the tool that I'm working with, and this is one of the newer lathe menus. They introduced this style of menu when they came out with the custom thread option a few years back. They started making the newer toolpaths with this situation here. But it's all the same stuff. You pick the tool, you choose your offset number, what turret you're using, upper left in this case, and what orientation is the tool starting at. Any extra approach and exit distances that you want to add to it, you can do so. And then you pick your chain. Right? If I go into my chain manager, you can see the chain I picked was that motion there. You got your different lead-ins and outs that you can add to it and extend it so that way the toolpath will go past it, go up and over, and be done with it. And then you have an automatic motion here, or you have a manual motion. And right now you can't see my lines because I have them hidden. So let me go ahead and turn those on. It'll be my red lines. There we go. So I have a set of motions in here. And you can see they're not in any particular order. If I start highlighting through these, you can see all these different lines. And lengths are also kind of irrelevant at this point. This location of where they're at does matter. So I had to create a type of pattern that allows me to start here, tilt upward, stay the correct angle here on the straight motions, and then start to tilt downward on all these different guys here. And once I put all these tilt lines on the screen, I can pretty much just window select them in here when I say modify selection or reselect all. I can do that window selection and they'll be all there. So it's just a matter of getting them on the screen first. And that's the fun part, messing with that offset angle. So let me get the toolpath back on the screen here and I'll show you a little bit of how this is behaving with those angles. You got different cut tolerances if you want to update your stock. Nothing too crazy in this. So let me get back in here. So what these lines do, and the way this toolpath is programmed, is off the actual center of the tool and center of the spindle as well, of your B-axis spindle. So that line is running straight through here. That's why it's perfectly horizontal. So a lot of times when I first started learning this, I thought I would have to program normal to this part of the edge, and that's not the case. It's normal to your actual spindle. So when I get up, I get to about here, and now normal to that. So all these motions come into play. Right? I don't need a lot of these lines in between here to here. I want to stay in that 45-degree angle the entirety of the time. And then I'll add this pivot line here. And once you get to these little crunches here, that's where you'll start to add more or less because you want it to go and behave one way and then start to move another way by the time it gets to this section. Right? If I got rid of these lines here, I would stay like this until I got to about here and it would roll in kind of funky. So I had to give it a little bit more detail there. And then I just kind of wanted it to roll up here, just because. Not necessary, but I was having fun with it. And there we go. So you use that combination of your turn profile to chain the part and then the tilt lines. And if a tilt line is bad, I just showed you this trick earlier. Let's say this part right here was not good. I can go to the Modify Length drop-down menu in the Wireframe tab and select Modify Vector. And all I got to do is pick that guy right there and then move it over X amount of degrees. Right? So it's a really quick fix when you start putting lines on the screen. What I really did was I just drew the basic ones. I did the 45-degree lines first. I put those on the screen, watched it behave, and then I added little angles from each one at that point. So that's how I came to get the result that I had in this part. I'm going to refresh this. So if I go ahead and machine simulate this in the mill turn environment, I've got my code expert opened up here. There's nothing to sync because it's only the two toolpaths on this file. There's only one turret. There's not two streams. You end up with really nice looking part file here. Turn all this off. There we go. So that first part was just roughing it, and then here comes the actual. See, it kind of goes a little fast. Real nice. So this will work with any machine that has a B-axis head on it. And I had a question on the rollout. Somebody had asked if I have a mill turn machine environment like this, but not the mill turn product in our Mastercam, can I still use this toolpath? And the answer is no. It is not in the normal lathe toolpath product at the moment. So you have to have the mill turn environment package to use it. Give you another little tidbit here. Earlier I said you can use an automatic boundary instead of a manual. So instead of picking axis lines, I can just say, go with the wind, right? And I can give it a limit. Hey, go from 0 to, I don't know, let's do 120. So it won't ever tilt more than that. When I hit the green check mark, regenerate, you'll see how the tool will think would be best for this part file. So it kind of goes a little different here. So I got some of what I wanted, just not everything. So I'm a big fan of using it manually, taking the time building my tilt lines, because I didn't like this dipping that happened here in the beginning. So that's the B-axis head there. Now I'm going to talk about steady rest support. In Mastercam 2022, we introduced the ability to use and set up steady rests. In this case, it was just single. You could use one. And now in 2023, we can use two. So if you've already used this motion in any of your files in 22, if I go to the steady rest operation in the mill turn product, I have steady rest motions here. If I go on the parameters for this one, I have the ability to choose one or the other steady rest that I have set up on this machine. This machine has a tandem steady rest, meaning both of them are connected onto one head. And I can choose to unclamp or clamp it. I can move it. I can retract it. All that motion. So when you set up your series of motions for your steady rest, you got all those there, and then you can start to program your actual file. And then on your pickoff support here, I'll just put it here for now. If I say pickoff cutoff, or pickoff, oops, let's say pickoff. In your pickoff options, you have the ability to say, hey, do a pickoff using the steady rest support as well. So without this option, you have the traditional motions. Hey, come bring it close, eject the part, get to your grip distance, pull it away. Now I can use pickoff with a steady rest, and I got all these extra steady rest operations that I can mess with. Which steady rest is moving where, how is it behaving, is it going to follow, that kind of stuff. I cancel that. Just going to reopen this file just to make sure and get anything screwy. So when I verify this in the simulation here, this one is a dual stream. As you can see, I have the two upper and lowers, and I have everything synced up already. You can see I have one sync to, don't do the space until all these steady rest ops are set. Don't do anything from here. So you can't move your spindle until you've done clamping, that kind of stuff. So you have to time when everything's happening here. If you don't do that, you're going to have crashes everywhere. So once you get all that set up, you can see the tandem steady rest set up in here. And I think I only had this front one here programmed to clamp the part. Grabs that. Just add a quick little rough there. And then here comes the gripping points. Oh, had a little finish there too. So now it's going to reposition itself and grab that. And this is going to clamp, and then both of them will clamp and move it over. And then it'll reposition so that way it's holding on to the far end there. And it's done. So this is with a tandem steady rest. And if you had individual steady rests, you can achieve this kind of stuff as well. So let me grab this other file here. Inside of here, I programmed this one a little different because I wanted both sides to start machining at different motions, at different points. So this is going to be using independent rests. Oops, wrong guy. Again, you would sync accordingly. And then you can launch it. And now you can see how I have the two different steady rests here. And in this one, like I said, it's kind of a little funny right at first because you don't see the stock here, but in reality, you'd have a part here already. So if I push play, what's going to happen here is this one's going to go grab that end, and this one's going to grab that end. It's going to work that, then it's going to work this section, and then it's going to grab this, move it over. And that's the end of that cycle. If I restart this and I put the loop button on, you'll see that kind of a mass production setting going on here. So now I got the actual gripping here of what would be happening. basically an endless cycle. So sometimes using the dual steady rest, if you have that capability, would be nice for something like that. And I've pretty much run the course here of what's new in the mill-turn and multi-axis products for Mastercam 2023.
Just again, thanks everybody for your time today. And stay tuned for some future webinars here. And Alex, thanks as well. Appreciate it.
No problem.
Everybody enjoy the rest of your Thursday. We'll talk to you soon.